So now we are on lesson 20 of the Doppler, and we're still talking about the Doppler effect. So remember, in the last lesson, I introduced you to this equation over here, where we said FL is the frequency of the listener, and then V is the speed of sound, and then VL is the speed of the listener, and then VS is the speed of the source, and then Fs is the frequency of the source. Additionally, you are also introduced to this equation over here, where this is the V is the speed of sound, frequency is of that wave, as well as its wavelength. And remember, velocity, the speed is measured in meters per second, wavelengths in meters. So this is V, this is wavelength, and then frequency is measured in hertz. I'm lying. Awesome. So now what our discussion is slightly going to talk about the 4 instances of the Doppler effect that you're most likely to be tested upon, especially in high school. So there's only 4. So the first one is that if you have a stationary source, so the source is not moving, meaning its velocity is 0, and then the listener, apologize for my spelling, is moving away from the source. So moving away from source. All right, cool. So in that case, we have a listener over here. This person is listening. The VL, they have a velocity, and then we have, let's say, maybe an ambulance or a car with a siren. It doesn't really matter. And the velocity of the car is 0 meters per second. It's not moving, it's stationary. Let's say it produces a sound with a frequency of 100 hertz, right? And so this person is now moving away, so meaning their velocity, this VL, is moving away. And we agreed that in the last lesson, that if this person is moving away, the frequency that they will observe, their perceived frequency, will actually be less than the frequency that is produced by this ambulance. So meaning that the frequency that they will hear is actually going to be less than 100 hertz, right? Okay, cool. So now what happens? So we introduced you to an equation over here. So remember, in questions, always start by writing the full equation as it is, include the plus or minus. Okay, cool. So now a question of, do I use a plus or a minus? Let us rewrite this equation. So you will say FL is equals to, okay, I'm not sure why I'm not writing this at the bottom. So you'll say, okay, FL is equals to, V is the speed of sound, VL is moving, I'm not sure as to at what speed. So it's moving, and then you say divide. So omit that plus or minus for now, and then VS is stationary, meaning at the bottom you'll only be left with V, all of it multiplied by FS. So now we can agree that for FL to be less than FS, the value in the numerator, the value at the top, so this is you consider this to be like a fraction. So this is the V. This part on top is the numerator, this part at the bottom is the denominator. For FL to be less, the value on the numerator must be less than the value in the denominator. This means that we must divide by a bigger number, right? So for these two things are equal, let's say they were like 340. So V and V is the same value. So for the value on the numerator to be less, it means that we have to minus, meaning that if that person is moving away, then this is the equation that we will essentially use. I hope that is making sense. Let us take up another scenario whereby now the source is still stationary, but the listener is moving. So stationary source. So the source is still stationary source, and then listener is moving towards the source, right? Cool. And then so this is you with your VL, FL, stationary source, you still have that ambulance with its wheels, Vs, it's stationary, so its velocity is 0 meters per second. Fs, it's still, let's say it produces a frequency of 100 hertz, like we mentioned, but now you are actually moving towards. So when you're moving towards, we agree that the frequency that you'll perceive is actually greater than this frequency that is produced by your source. So now we go back again to our equation that says that FL equals to V plus or minus VL, all of it divided by V plus or minus VS, which is all multiplied by VS, right? So now let's rewrite it again. So then you would say, okay, so I have V, you omit any that for now, and then you divide it. The source is stationary, so at the bottom you are left with V, and then you have the frequency of the source. So now we can agree that for FL to be greater than FS, we have to divide by a lower number. So the number at the numerator must actually be greater than the number at the bottom. Remember, these two values are the same. And for this value to be greater, it means that we actually have to add. Then you'll actually find a frequency. This frequency will actually be larger than this frequency over here. So that is another scenario that we can. Another scenario that we can have is that we can actually have, I'm trying, not remove this. So now you as the listener, you are stationary. So now you are stationary. So listener stationary. So you're not moving. And then the source is moving towards you, right? Moving towards listener. So the source is moving towards you as the listener. So you are stationary. There we are. You are stationary, so your VL is actually 0 meters per second. And then this car is actually now moving towards you at a certain velocity. So Vs is no longer 0. It's still producing the same frequency of 100 hertz. So now we rewrite this again in when you're doing a calculation. Then you say V. At top you only have V because VL is 0, right? And then at the bottom you have V, Vs, Fs. And then now we say, okay, if they are approaching each other, the perceived frequency will actually be greater than the emitted frequency, or the frequency of the source. This means FL will actually be greater than 100, right? And for that to be, it means the value on the numerator must be greater. So we must divide by a lesser number, meaning here we would actually have a minus to make the denominator, just considering this part, to make this denominator between these two to be lesser than this. So we want V minus Vs to be lesser than V, right? Okay, so now another situation would then be a similar situation. The listener is still stationary, but now the source is moving away. Source moving away. So instead of approaching, it's now moving away at a certain velocity. So now it's moving away at a certain velocity. If it's moving away, let me wipe this. If it's moving away, it means that the perceived frequency will actually be less than the frequency that is coming from the source. We still start with your equation in full, and then you say, okay, at the top you still have V because the speed of your listener is 0, and then you have V, Vs, Fs. Okay, so now for FL to be less, you have to divide by by a bigger value. So the value at the denominator must be greater than the value of the numerator, and for that to be, we'll have to add these two values together, and then that will be the fourth instances. So those are all the instances that we can refer to in your syllabus at high school that you must be familiar with when we're working with the Doppler effect. And I hope that kind of clears the confusion that students normally come across in terms of when do you use a plus, when do you use a minus. And then this brings us to the end of this lesson. In the next lesson, we actually going to talk about, so that was lesson 20. I'm trying to find, we're going to talk about Doppler effect as proof of an expanding universe, as well as mention a few applications of the Doppler effect.